Okay, Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Okay, today you will learn surface integral of vector field. Okay, a surface integral is an integration over a surface. So here we have surface S and we want to integrate over this vector F. So if vector F represents the flow of the fluid. Okay, let's say F is the vector. We have vector F. Vector F is the flow of fluid. Okay, for example, flow of water. Then surface integral of F is surface integral of F ds. Okay, will give you the amount of fluid flowing through the surface. Okay, you will get amount of fluid flow. Okay, for line integral, you do single integration. But for surface integral, you have to do double integral. So this is the formula. It is given by double integral of F. This F is the vector. Okay, dot product with ds. This S is represent the vector of S. So equal to F given by this formula. F dot n. N is the normal vector of surface ds. Okay. If you look clearly, you can see that ds here we change to this one. Okay, so to get surface integral of flux, so to calculate surface integral, we must have the vector and the normal vector of the surface, and also the limit. Okay, since we are dealing with surface, so the type of surface is very important. We have parametric surface and also non-parametric surface. The non-parametric surface is when the surface is represented as relationship between x, y and z. Okay, for example, circle. We have x square plus y square equal to 4. So other example of non-parametric surface is ellipse, paraboloid, triangle, tetrahedron, and cuboid. Okay, for parametric surface, the surface is not represented as relationship of x, y, and z. Okay, for example, sphere. This sphere can be represented by other variables, other independent variables. So we have r, theta, and also phi. To calculate surface integral, it is very important that you differentiate between parametric or non-parametric surface. The figures or the graph for parametric surface and non-parametric surface. Okay, please copy this note. Example of cylinder. Okay, if you see from the question, surface S bounded by equation x square plus y square equal to something, equal to constant, and given, okay, this is z. Z is between 0 and 5. Okay, this is example. The surface refer to cylinder. So for surface integral, we're dealing with 3D graph, 3D coordinates. This is x, y, and z. So cylinder, you draw cylinder. We have circle. Circle juga. And we have. So this information refer to cylinder, surface of cylinder. Okay, for this example, The radius equal to, you can change to r square, 3 square. So 3. This one also 3. And z. Z is from 0 to 5. So 0 to 5. So here 5. The height of the cylinder equal to 5. Okay, so if you see from the question, the surface is bounded by x square plus y square equal to 25. And z is between 1 to 6. Okay. X, Y, Z. Here you just change. You have cylinder here. So the radius you refer to the constant value. Okay, so 5 square. So the radius is 5. Z equal to 1. Here. 1 to 6, right? Okay. This is 0. X, Y. Okay. So the cylinder start here. Okay, next sphere. Okay, this is sphere. Okay, for example, so this is the equation for sphere. So 4 here refer to radius. Radius of sphere. R square juga. So R equal to 2. Okay, sphere. Then we move to non-parametric surface. Tetrahedron. Bentuk triangle. Triangle in 3D space. In question will see surface. Okay, given surface of z equal to 4 minus x minus y. Okay, when you see this, it is referred to tetrahedron. To draw tetrahedron, first we assume x equal to, you assume x equal to 0. Here x equal, x equal to 0, y equal to 0. And you will get z equal to 4. Substitute here. 0, 0, so z equal to 4. Then the points will be z equal to 4. Kita dapat 4. Okay, 4 and 4. So connect all the... So the surface is actually here. In 3D space. Triangle in 3D space. Okay, next we have paraboloid. Okay, this is the surface. Z equal to 16 minus x square minus y square. And we have a extra information. Above xy plane. Okay, or when z equal to 0, it refers to the same meaning. Okay, this is paraboloid. It is different with hemisphere. So, hemisphere? Half of sphere. Okay, this is hemisphere. But this one is paraboloid. Dia lonjong sikit. X, Y, Z. So the radius here refer to this one. The radius equal to 4. 4. Okay, above XY plane. Okay, if the question state that Z is between 0 to 6. So this here hujung ni equal to 6. 0 until 6. Okay, this is the formula to find surface integral. Okay, for parametric surface, and this one is for non-parametric surface. So the first step is to find this one, n. Okay, unit normal vector. Unit normal vector of surface. So for parametric surface, the normal vector is given by this formula. So del S equal to del S over del S Y del S over del Z. And then this one is the magnitude of del S. Okay. For non-parametric surface, N here, you can refer from this table. The values for the formula for N, unit normal vector. If the equation in the form of Z, Z equal to X in the form of X and Y, then you refer this formula. And then we have positive and negative orientation. Okay, just look at the question. This column refer to when you see the equation in the form of y equal to something, y equal to xz. For example, this one, z equal to 16 minus x squared minus y squared. Okay, this one, y equal to 2 minus z squared plus 2 minus z. Here, x equal to y squared plus z squared. Okay, let's look at how to solve parametric surface. Okay, this is the formula to find surface integral. We have f dot with n. So first step is to find n using this formula. Okay, then calculate this pair, okay, f dot n. And then number 3, convert to polar coordinate. Convert this f dot n to polar coordinate. We have cylinder, we have sphere. And number 4, determine the limit. And number 5, solve. Let's recall polar coordinate. So this is the polar coordinate. Okay, we have Cartesian coordinate x, y, z and polar coordinate. This is polar coordinate. Polar coordinate is in the form of r. R is the radius and also the angle. So this is the coordinates for plane. Okay. And this one polar coordinate for cylinder. And this one is polar coordinate for sphere. Okay, this one. Step number 3, you change from x, y, and z to polar coordinate in the form of r, theta, or phi. So let's look at example 1. Okay, evaluate the surface integral for this vector, vector f. Okay, and S is the surface of region bounded by cylinder. Okay. Cylinder between the plane z equal to 0 and z equal to 3 in the first octant. Okay, we have extra information here. Octant. What is octant? If we have these 3 coordinate, x, y, and z, you can divide this 3D coordinate to 8 regions. So the first region is here. This is the first region. This one is second, third, fourth. This 5 here kat bawah, 5, 6, 7 kat belakang, 8 here. This is the octant. So we want to consider the surface here in the first octant only. So here. So for this example, we want to consider the surface in this octant, in this region only. So this is the graph. We have cylinder. X squared plus y squared equal to 4. At x and y plane here refer to a circle. X squared plus y squared equal to 4. At xy plane, this is circle with radius 2. And then z is from 0 to 3. So 0 to 3. Okay, first step to find surface integral is to find n. Net normal vector. Okay, equal to gradient of S divided by its magnitude. Okay, our surface here is the circle. S equal to xy plus y square equal to 4. So del S equal to differentiate S to x, to y, and to z. Then we'll get 2x, 2y, and 0. And then find the magnitude. So we have 2x square plus 2y square plus 0 square. And we get 4x square plus 4y square. Then factorize 4. We get x square plus y square. Okay, so we know that x square plus y square equal to 4. Then substitute the values. So 4 multiplied with 4 square root equal to square root 16 to 4. So n equal to 2x, 2y, and 0 divided by 4. Okay, step number 2, find f dot n. Okay, just dot product. F equal to y, y, z, 2x, y, z, 2x. Dot product with 2x over 4, 2y over 4, and 0. This is n. And then we'll get xy over 2 plus y over 2 plus 0. And factorize 1 over 2. Okay, step number 3. Okay, convert to polar coordinate PC. So, convert f dot n. We have f dot n equal to half xy plus zy. So, for cylinder, this is the polar coordinate. You just substitute x here with r cos theta. Y is r sin theta. Okay, z equal to z. R cos theta okay, step number 3 is to convert to polar coordinate. Okay, step number 4, determine the limit. Okay, so you must refer to your graph. F dot n ds equal to f dot n is here. Substitute here. Panjangnya. This is f dot n. ds here. Okay, ds is given by this one. R dz d theta. Then multiply r. R here, you substitute the values. Okay, from the figure, r equal to 2. Then we'll get cos theta sin theta plus z sin theta dz d theta. Okay, then we determine the limit of z and also theta. Okay, here you put limit for z, and this one you put limit for. So for z we know that from the question z is from 0 to 3. So 0 to 3. For theta is the angle from x, from x-axis. So for this example, theta is from 0 to pi over 2. Okay, 90 degree. So 0 to pi over 2. First, you must integrate to z. and then you integrate to theta. You will get to z, you will get 0 pi over 2. So if you want to integrate to z, other variable you treat as constant. So theta you treat as constant. So we get 4 cos theta sin theta z plus 2z square over 2 sin theta, where z is between 0 to 3 d theta. Okay, last answer will be 15. Okay, try to do it. Okay, next I want to show you example 2. Calculate flux. So calculate flux. Flux refer to surface integral. Okay, for vector field, okay, this vector field F across surface S, which is an upper hemisphere. Hemisphere is half of sphere. So this equation refer to sphere. And okay, the first step is to find
Unit vector of surface.
So our S here is equation for sphere. And then to find del S, differentiate this S to X. Okay, that's why you get 2X here. And then differentiate to Y, you will get 2Y. And then differentiate to Z, you will get 2Z. Okay, and then we find the magnitude del S. When you simplify, you will get 4 multiply with x square plus y square plus z square. Okay, refer to the equation. Okay, this one equal to 16. So 4 multiply with 16, you will get, and then square root, you will get 8. Okay, so this is n. Okay, next find f dot n. Okay, f dot n, 2x multiply with 2x over 8. And then simplify 4y square over 8 plus 4z square over 8. Then simplify. 1 over 2, 1 over 2 over 2. And factorize. Okay.
Then we get this answer.
Step number 3. Okay, convert x, y, and z to polar coordinates. Since this is sphere, then you use polar coordinate for sphere. So we have x equal to r sin theta cos phi. We have extra variables here, phi. So what is phi? What is theta? We have sphere. Okay, r is the radius. Okay, line from origin to point on the curve of sphere. This one is r. Also this one that touch the curve. Okay, r juga. This is r. Radius.
Meanwhile, theta is
Okay, the angle between R and Z axis. Okay, this one you must know because we want to determine the limit later. So this is theta. Phi equal to angle at XY axis. Okay, this one. Okay, this is phi. Okay, then you transform or you change X, Y, Z to polar coordinate. Okay, you can see here. Okay, cos square phi plus sine square phi equal to 1. Then we get f dot n equal to this value. Okay, step number 4. Okay, we want to determine the limit. This is f dot n. Okay, you substitute f dot n here, and ds. The s here given by r square sin theta, panjang ke, d theta d phi. Okay, just substitute here. And then simplify. Simplify, you put values of r. Here r equal to 4. This is r square. Simplify, substitute r equal to 4 in the equation, and you get 128 sin theta d phi. Okay, and then you simplify. So, how to determine limit? Okay, first, sama juga tadi. First, this one is limit for theta. And this one limit for phi. So, for this example, okay, theta, remember theta is between line of radius, this line, to angle, to z-axis. Okay. So, 0 to, this is sphere. So, the line, this is r, radius, and this is z. This is z. Okay, we want to determine the angle here. This angle is 90 degree.
Limit of theta is from 0 until pi over 2.
Okay, for phi is the angle of xy plane at xy plane in dekat circle. So we have full circle. That's why the limit is from 0 to 2 pi. Okay, and then solve. Pi equal to 180 degree. 1 pi. So pi over 2 equal to 90 degree. Okay, if we consider, if the question is for what? Full sphere. So your limit will be for d theta and d phi.
So limit for theta will be from 0 to pi, okay, 180 degree. And limit for phi is from 0 to 2 pi, 360 degree. Okay, for this question, after you determine the limit, step number 5, solve the integration. Then we get 256 pi. For today's lesson, you have learned about surface integral for parametric surface. Okay, which is cylinder, sphere. Okay, the first step to find surface integral is to find the unit normal of surface, which is given by formula gradient of s over its magnitude. Okay, and then step number 2 is to find the product of vector with the unit normal vector. And then step number 3 is to convert xyz to polar coordinate. And then step number 4, okay, determine the limit of integration, okay, by using graph. And the last one, let's solve the integration. Okay, that's all for today. Thank you guys.